Okay, so let's get started here. We're going to still talk about factoring quadratics. Okay, something we've already talked about yesterday. Okay, but today we're going to focus on a greater than 1. Okay, and you might be wondering, where's this a coming from, right? Remember, yesterday I kind of showed you. Yesterday we did problems that looked like this. X squared plus bx, okay, plus c, where b and c are numbers, right? I'd like to zoom in maybe some more there. Okay. So right, this is what we looked at yesterday. We had a 1 in front of the x squared for all the problems. Then we had bx plus c, right? These numbers would change. The b and the c, those are the ones that changed. And so that would create, your different problems and stuff. Today, we're now going to have ax squared plus bx plus c. So we're going to throw in another number, okay, in front of the x squared term besides 1. So that's why it's a greater than 1, okay. So that's what we're looking at today, okay. So let's refresh our memory, right, just to make sure we're cool with it. So factoring when a equals 1. Actually, let me write that. So factoring when a equals 1. Okay, so this is what we did yesterday. I'll just do a quick example here just so you can see that, and then we'll compare it to what we did, what we're going to do today. So x squared plus 9x plus 18. Okay. X squared plus 9x plus 18. Okay. What were the key things we wanted to do here to actually factor this? Okay. We knew we had to have an x and an x in both of our binomials. But the two numbers that go in here, right, these numbers that we fill in, they have to follow kind of two rules, right? They need to multiply to make what? 18, right? They have to multiply to make this last number, but both numbers also have to add to make what? The 9, okay? So multiply to make 18, and then add to make 9. Okay, and so what are those two numbers? Yeah, 3 and 6, 6 and 3. Yep, so x plus 3, x plus 6. Okay? That was yesterday, right? That was yesterday. Easy stuff, okay? The x squared, it's easy to get x squared. The only way you can get x squared is by doing x times x. So that's why you have the two x's there, okay? Now, let's take a look and compare that to factoring when a is greater than 1. Okay, and I'll do a little example here. So let's say we want to factor 3x squared plus 10x plus 7. All right, I'll kind of pause there. Yep. I'll is that good enough right there for you? The top is like there. All right, so I'll do that there for you. Okay. I can move it up? Okay, thank you. Okay. So let's see if we can follow our same rules here, okay? So let's see. Can I start out with x and x like I did last time?
No.
Is that going to work this time?
No.
Why not?
Because a is not equal. 3x squared.
Right, yeah, a is not equal to 1 here. If you think about this, if I were to re-multiply this, x times x, what's that give us? X squared. What do I need according to this, though? 3x squared. Okay, so we can still kind of fix that, though, right? We can still kind of fix that. Right now, if I were to just multiply, it would be x times x. It would give me x squared, but I don't want just x squared. I want 3x squared. So how can I fix these x's so that I would end up with 3x squared? Yeah, give one of them a 3. Just give one of them a 3. Like, make this one 3, we'll say. Okay, now when I multiply 3x times x, that gives me 3x squared. Aha, okay? So that was a pretty easy way to fix that. Okay? And now the rules still kind of apply here. I still want to multiply to make 7 and add to make 10. Okay, the rules are still going to apply there in that case. We still want to follow those general guidelines. We want to multiply to make 7 and add to make 10. Okay, so let's think about that here. What two numbers multiply to make 7? 1 and 7. And are there any other ones? No. Okay, so we could say 1 and 7. But then, do 1 and 7 add to make 10? Right, so we have to be careful here though. It's not 1 and 7 that we're going to be adding together, because depending on where I put that 1 and the 7, right, so let's say for example I put the 1 here and the 7 here. Okay, plus 1, plus 7 like that. Let's say I put the 1 there and the 7 there. The 1 is going to multiply with what? The 1 will multiply not with the 3x, it's being added with 3x. Oh, no. The 1 multiplies to what other two things? X and 7. So it'll be 1x. Okay, so I'm going to get 1x there. And then what does the 3x multiply with? The x, but also the 7. So what's 3 times 7? 3x times 7? 21x. So I'm going to get 1x plus 21x, 22x. Is that what I wanted? Yeah, no. So I don't want to put the 1 here and the 7 here. I want to flip them. I want to put them in the other place. So this was not right. I actually want to do 3x plus 7 and the 1x plus 1. Okay, now if we do that, we'll get 3x times x, 3x squared, 3x times 1, 3x, 7 times 1, 7x. So 3x and 7x, that makes 10x. And then finally 7 times 1 makes 7. Okay? Question on anything? Okay? So this is how, that's kind of like the way to do it, the old way. Okay? If you want to try and do it. You can kind of like, almost like a guessing and checking kind of thing. You say, okay, well I know I need to multiply and make 3x, so that's got to be 3x and x. I know I also have to multiply and make 7, so I can do 1 and 7, or I can do 7 and 1. Well, in this case it was the 7 and the 1 that we wanted there like that. Okay? And there's our final answer. Okay? But that still makes things kind of complicated, right? Because, you know, you could have other options. For example, if this were 4x squared, okay, so let's think about it this way. If I had 4x squared here, well, that means I could do 4x times x, or I could do 2x times 2x. And then you have a lot of different options to consider and stuff like that, and it makes it kind of tricky. Okay, but there is a trick that I've heard called slide and divide, okay, that will convert a problem like this back to one of the problems like we did yesterday. Okay, so slide and divide. Let me show you how this works, and I'll do it back with the original problem we did there. Okay, so if this thing here was too complicated for you, or you weren't really sure, you know, or just like this is too much, you might think, you know, pay attention to this because this makes it a little bit easier. Okay, so this method again is called slide and divide, and that's because you do two kind of things here. The first thing you do is you slide back the 3 and multiply it with the 7. Okay, so there's the slide part. And so I'll even write that here. So multiply, okay, 3, which is the lead coefficient, okay, to the last term. Okay, so we're taking the 3, we're going to slide it back and multiply it to the 7. Okay, and by sliding that 3 back, we're going to then have x squared, right? The 3 slides away back to the 7 there. X squared plus 10x plus 21. Okay, so the 3 slides back to multiply with the 7, and so we get this new problem. Okay. these two things are not equal, but we're going to use this one. We're going to use that x squared plus 10x plus 21 to help us then factor this. Okay, so again, these two things are not equal to each other, so I'm not writing an equal sign there, but we're going to use this bottom one here to help us factor this top one. Okay, because now, look at this. What's our a? Well, what's the number in front of the x squared? So 1. So now we can use those rules that we learned yesterday. So to factor this thing, we want to find two numbers that multiply to make what? We want to multiply to make 21 and add to make what? 10. Okay, so what are two numbers that multiply to make 21 but add to make 10? 7 and 3 or 3 and 7? Okay, so you factor like normal. Okay. And here's where the divide part comes in. Okay, again, remember I told you that this quadratic, x squared plus 10x plus 21, is not equal to this quadratic. And so therefore, this, 3x squared plus 10x plus 7, this is not equal to x plus 7 times x plus 3. So these two things are not equal. This is not your final answer, but we're almost done. Okay, remember this method is called slide and divide. We did the slide part, now we're going to do the divide part. Okay? We're going to divide by 3. Okay, but the only thing we're going to divide by are the numbers. Okay, 7 divided by 3, and then 3 divided by 3. Okay, and then with that division, we're going to simplify. Okay, so does the fraction 7 over 3 simplify? Yeah, it does not. And if you're not sure about that, you can check that easily with your calculator. Remember, just type in 7 over 3, math, enter, enter, and it stays 7/3. So that does not simplify. Okay? So that doesn't simplify. Does 3 over 3 simplify? What is that equal to? 1. Yep. So I shouldn't really put an equal sign there. Okay. Okay, and then here's the last thing. Simplify, and we're going to move the denominators out front. Okay, so the 3 here, since we still have a denominator left, this 3, it's going to slide out in front of the x there. Okay, and so our final answer is 3x plus 7 times x plus 1. And that's your answer. Okay, so that is the factored form. Right? Remember, that's one we got earlier. 3x plus 7, x plus 1. 3x plus 7, x plus 1. Okay, it's the same thing. It works. All right. And so we'll take a look at a few more of those before we move on here. It's a little bit tricky. It's one more kind of additional thing we have to do. That's all. Okay, I was going through that one very slowly, but let me show you, we can go through a little bit quicker. So questions on any of that? We'll do a few more here. Okay, I think I have 3 more, it looks like we'll do at least. Okay, so let's try another one. All right, so again, our directions are to factor. Okay, so let's see, this one. Yeah. Yes. 2x squared plus 11x plus 12. All right, so I'm going to pull this one away here. 2x squared plus 11x plus 12. All right. All right, so again, if you look at this here, right, there's no GCF to factor out, right? This is divisible by 2, and this is divisible by 2, but 11 is not divisible by 2, so we can't factor any GCFs out. And so we have to kind of deal with the fact we have a 2 here in front of that x squared term. Okay? So let's slide. So we're going to take that 2x squared and slide it back, or the 2 from the 2x squared and slide it back. Okay? All right, and so what will that make it? The 2 is gone from the x squared term, so now it's x squared plus 11x plus, 24. You got it, Gabe. Exactly right. Okay. There you go, sir. Okay. And now we're going to factor this. So we're looking for two numbers that multiply to make what? Multiply to make 24. That's right. So, and we want to add to make what?
11.
Yeah, add to make 11. Okay, so can anyone think? Two numbers that multiply make 24, but add to make 11. What are those going to be? Addie? 8 and 3. You got it, Alex. That's what you were going to say too. 8 and 3. Good job. Very good. Okay, so then this becomes x plus 8, x plus 3. So we did the slide, and now I got to do the divide. So actually I'm going to divide by, and what am I dividing by? 2. 2, right? We slid the 2, we're going to divide by 2. Okay. And we simplify. Does 8 divided by 2 simplify? 4, right? And so yeah, so this just becomes x plus 4. Okay. Does 3 divided by 2 simplify? No. And so we're going to leave that as x plus 3 over 2. And then remember the denominator slides back in front here of that x. And so we get x plus 4 times 2x plus 3. And there's the answer. Okay? This and this are equal. Okay, those two things are equal. All right? Try another one here. Question?
Was it like, with slide and slide over?
It should, yes. The only thing you want to make sure that you do, so first of all, it will always work if the thing factors in the first place, right? There are some problems, and we haven't really run across these because I didn't want to, make it even more complicated. But there are many problems. If you just so for example, Alex, if you were to just if I were to tell you, Alex, make up a quadratic, and you would sit there and you'd say, I don't know, Mr. Wood, let's say 7x squared plus 10x minus 3. If you were to make a problem up, most of the time it wouldn't factor. Okay, so the majority of quadratics, if you just pick random numbers, it won't factor at all. Okay, so we pick specific ones that do factor just so we can get the practice in of factoring. Okay, but many of them don't factor, or they wouldn't factor to numbers that we know. Okay, or we can easily find. So that's one thing we look out for. And the second thing is you always want to check to make sure you factor out that GCF. Just like yesterday where we had those 3 problems that you had to pull the 2 out first and then factor it. That's what you want to do here too. So factor out the GCF first, and then if it factors, the slide and divide should work. No problem.
So anything that take out, try to take out.
Yeah, exactly. Okay, so let's do 2 more here. So 5x squared plus 9x minus 2. Okay, 5x squared plus 9x minus 2. All right, Jordan, what's going to be our first step here? How do we do this? X squared, okay.
X squared, and then you're going to make it
Yep, 5 slides back to the what?
back to 2.
Back to the 2, right? And so then instead of 5x squared plus 9x minus 2, we slide it back, right? And you don't have to write the word slide. I'm writing it just for the notes here.
Okay.
And what is that? What's our term going to be here now?
I think it's minus 3x squared.
When we slide it back, we multiply. So
so
slide it
yeah,
back.
10x.
So minus 10. Just minus 10, like that. And now we're going to try and factor this. So does this factor, Jordan? We need 2 numbers that multiply to make negative 10, but add to make 9.
Yes.
Okay, so what are those going to be?
X plus
plus
And
10,
then x minus 1.
x minus 1. Yep, exactly right. Okay, very good. So that does factor to x plus 10, x minus 1. And then we're going to do the divide part, right? So now we're going to divide each of these by what? By 5, yeah. What we slid there. We slid the 5, so we have to now. So basically, it's like if you think about it, it kind of makes sense, right? We slide the 5 back and multiply it with the 2. Now we're gonna undo that. So we multiplied the 5. Now we're gonna divide the 5 to kind of undo what we just did to kind of correct it there. Okay. Does 10 divided by 5 simplify, Jordan?
Makes 2.
Makes 2. So we have x plus 2. And then does 1 divided by 5 simplify?
Yeah, one negative 1/5.
It's just 1/5, right? So it doesn't simplify. So then we'll slide that back in front of the x there, and we have 5x minus 1. And there's our answer. This is equal to that right there. Okay, they're the same thing. That's it. Okay, a little tricky. All right, we'll do another one here. All right, let's factor 4x squared plus 4x plus 1. In fact, why don't you guys go ahead and give this a try, okay? Try this one here on your own. 4x squared plus 4x plus 1, okay? I'll give you, you're going to have to slide and divide, okay? You're going to have to slide and divide, so give that a try. Okay, you're going to have to slide and divide it. Come around and help as necessary here. Okay, so again, try and factor. Remember, slide and do the divide, right? Slide, factor, and divide. Slide, factor, and divide. Slide, factor. Yep, good. You simplify the fraction. Yep, good job. Exactly right. Looks good. Remember, you can always tell, Gabe, too, if you remultiply your answers together, you should end up back with this. So, and that also is a way you can check. Yeah, add a question. Multiply to make 4, but also then add to make 4. Make sure you remember to multiply to make 4. Right? No, well, sometimes it can be like, wait, multiply to make 4? I know, yeah, it's really weird, but no, yeah. So you simplify. And this is like one how to get include the slides out front. So it's 2x plus 1, 2x plus 1. So, yep. Good job. Yeah, yep. Okay, good. Noise. Now you factor what you normally do, right? Like we did yesterday. So you're looking for two numbers that multiply to make and add to make. So you're making it too hard. Give me two numbers that multiply to make 4. 1 and 4. Okay, do they add to make 4? Nope. Okay, think of two other numbers that multiply to make 4. Do they add to make 4? X plus 2.
I think I came in.
Now, this is where we do the divide part, right? You slid the 4 back, now we're going to divide both the 2's by 4. The same thing you slid by. What is that? Over 4. Now, those fractions simplify. 2 over 4 is like 1/2, exactly right. So why don't you write that out? X plus 1/2 times x plus 1/2. So then, now you have these fractions. You have fractions still after the prime, you slide the 2 back in front of the x. So it becomes 2x times 2x plus 1. Right? That's your prime. Okay? And 2x plus 1 times 2x plus 1. So put parentheses. Okay, that's right.
Is this right?
Close. Let me see here.
This is the original.
Right. Okay, you slid it back there. Okay, so yeah, so this, what is this factor to? And it should be plus 4, right? Okay. So you think of two numbers that multiply to make 4, but add to make 4 as well.
Oh, so we're just doing how we did it down here?
Yes, you do this. Yeah, exactly. So once you slide it back, you then look at this and you say, okay, what are two numbers that multiply to make 4, but also add to make 4? And then you go through the divide part. We'll go through it here, right, so you can see it too. Okay, let's take a look at this here real quick. All right, so we're going to factor this one, and I'll get you guys started on your assignment here. Okay, so let's take a look at this. All right, Dorian, go back to your seat. All right, thank you, sir. So again, we've got 4x squared plus 4x plus 1. We can't factor this like we were doing yesterday yet because we have that number 4 in front. But we can use slide and divide, right? We slide that 4 back, and so that now becomes x squared plus 4x plus 4. Okay, so there's the slide. Now we can factor this like we did yesterday. Okay, and how does this factor? How does this factor? What does it factor to be? X plus 2, x plus 2. Okay, right? X squared plus 4x plus 4 is x plus 2 times x plus 2. Now we factored it. We have to do the divide part. So we slide, and now we divide. And what do we divide these two numbers by? 4. Okay, what we slid. We slid the 4, so now we have to divide by 4. Okay. Does 2/4 simplify?
Yes.
To what? 1/2. Yeah, so this becomes x plus 1/2, x plus 1/2.
And the 2 pairs over to
And then, right, we slide the 2. They both have denominators. Both denominators we slide back out front, so it becomes 2x plus 1 times 2x plus 1. Okay, and so that is what that problem factors to be. 2x plus 1 times 2x plus 1. Okay, did anyone write it this way? 2x plus 1 squared? Because you could, because it's the same thing, right? So that'd be 2x plus 1 squared. So good question, right? Why don't we just leave it as 1/2 plus 1/2? The answer is because if you were to multiply this out here, it would still not give us, it would not give us this. Like, this is not our final answer, okay? So, like, there's just basically, it's like one last little thing you have to do here with the denominators is just slide those back out, and that then finally gives you something that is answer here, right? X plus 1/2 times x plus 1/2. If you were to FOIL that out, it would not give you this. So it's just like a little correction that we're doing there, Colin. And I know it doesn't really make sense. I mean, I'm sorry, there is reason behind it, but you know, even I'm not sure how this like method kind of works. But I know that it does work. Okay. The only other option that I could tell you here, like Colin, if you wanted to kind of do it in a way that maybe like quote unquote makes sense, okay, I can show you here real quick. I mean, so the other way that you can think about doing these problems. Okay, is you basically do it like we did yesterday, okay? You look at it and you say, okay, I know that I need to multiply to make 4x squared. That means I need an x here, I need an x here, but I need more than just x, right? Because they need to multiply to make 4x squared. So I could say like 2x and 2x like that. You see what I'm saying? I'm just like saying, I need to get 4x squared so I can make that 2x and 2x, that'll make 4x squared. And then again, you pick your number here. Well, this one's pretty easy. I need to multiply to make 1 and add to make 4. Well, the only way to multiply to make 1 is just 1 and 1. And sure enough, 1 times 2 is going to be 2x, and then the 1 times 2 here will give me another 2x, and so that makes 4x. So you can also kind of guess and check it, too, if you prefer. So does that kind of make sense? The problem with this method, Colin, is that I could have done 2x and 2x like I did, or I could have started with 4x and 1x, right? I could have gone to this because 4x times 1x, that gives me 4x squared. And then again, same principle, I need to multiply to make 1, add to make 4. Well, that would have to be 1 and 1 here. That's the only two options I have. But you can see why this one doesn't work. I would get 1 times 4, which is 4, 1 times 1, which is 1, 4 plus 1 would give me 5x there when I pull it back out, which is not the 4x one. So that's why that one, you know it's got to be that one. So, I mean, there's kind of two methods. You can do what we did yesterday, but that requires some more like guessing and checking in a sense. Or you can do it this way, which works every time, but it's a little bit of trickeration, I guess I'll say. So it's like up to you which way you want to go. Okay?